FastMCP2 employs dependency injection to resolve runtime values, enabling clean separation between client-facing parameters and internal dependencies. This mechanism automatically excludes dependency parameters from the MCP schema while providing necessary context during execution. The upcoming code demonstrates how to extract specific claims from authentication tokens using TokenClaim, which directly injects claim values like user identifiers without requiring the full token object. This pattern simplifies access to provider-specific claims while maintaining security and clarity in tool definitions. From FastMCP, import FastMCP. From FastMCP server dependencies, import TokenClaim. MCP equals FastMCP demo. At MCP, tool. Async def at expense. Amount, float. Userid, SDR equals TokenClaim void, hash Azure object ID. Dict. Await DB, insert user ID. Userid amount. Return status. Created userid. This code demonstrates FastMCP's dependency injection system for extracting specific claims from authentication tokens. The TokenClaim void dependency automatically retrieves the Azure object ID claim from the authenticated user's token, injecting it as the userid parameter. This approach eliminates manual token parsing and claim extraction, reducing boilerplate while maintaining security. The pattern leverages FastMCP's built-in dependency resolution, where TokenClaim acts as a specialized dependency that targets individual JWT claims. When the tool executes, FastMCP validates the token's presence and extracts the specified claim, raising a runtime error with available claims if the requested claim doesn't exist. This is particularly useful in microservices, where user context must propagate through multiple layers without explicit parameter passing. The trade-off here is between convenience and explicitness. While TokenClaim simplifies code by directly injecting claims, it creates an implicit dependency on the authentication system. Developers must ensure the claim name matches the identity provider's schema. Azure uses void for user IDs, while others like Auth0 use sub. The error handling helps mitigate this by listing available claims when a mismatch occurs, but it still requires awareness of the provider's claim structure. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core server functionality for the Model Context Protocol MCP framework. This class serves as the base for creating FastMCP server instances. From FastMCP server dependencies, import TokenClaim. Imports the TokenClaim class from the FastMCP server dependencies module, which provides functionality for handling token-based claims in the FastMCP server context. MCP equals FastMCP demo. Creates a FastMCP server instance with the identifier demo. The string parameter serves as a server label for identification in MCP protocol handshakes, but doesn't configure functional behavior. This instantiation establishes the base server object that can later be mounted with components or tools. At MCP, tool. Async def at expense. Declares an asynchronous function named @expense and registers it as an MCP tool using the @MCP tool decorator. The decorator automatically configures the function as a callable tool within the FastMCP framework, using its name as the tool identifier and generating input validation based on its parameters. Userid, SDR equals TokenClaim void, hash Azure object ID. Declares a variable userid with type annotation, SDR, and assigns it the value returned by TokenClaim void, which extracts the Azure Object ID claim from a token. The comment clarifies that this represents an Azure Object ID. Await DB, insert user ID, userid amount. Asynchronously inserts a document into the database containing two fields, userid with the value of the userid variable and amount with the value of the amount variable. The operation waits for the database insertion to complete before continuing execution. Return status, created userid. Returns a dictionary with two key value pairs. Status, set to the string created, and userid, set to the value of the userid variable. This appears to be a response payload indicating successful creation of a resource, with the newly created user's ID included for reference. FastMCP2's dependency injection system elegantly bridges the gap between clean API design and secure authentication workflows. By using TokenClaim OID as a parameter default, the framework automatically handles JWT claim extraction while keeping the tool signature focused on business logic. This pattern demonstrates how FastMCP maintains separation of concerns. The @MCP tool decorator manages schema generation and validation, while TokenClaim handles the implicit authentication context. The trade-off between convenience and explicitness becomes clear. Developers gain cleaner code, but must remain aware of their identity provider's claim structure. The error handling that lists available claims when a mismatch occurs serves as both a safety net and a reminder of this implicit contract. Ultimately, this approach allows tools to remain provider-agnostic in their implementation, while still leveraging provider-specific claims through configuration.
The decorator chains the function to Azure's claim. Yet the function drifts away like a cloud from a mountain.